In this lesson, we're going to cover volumes of known cross-sections. This example says the base of a solid is the circular region in the xy plane, bounded by the graph of x squared plus y squared equals a squared, where a is positive. Find the volume of the solid if every cross-section by a plane perpendicular to the x-axis is a square. So we have this equation, which is a circle with center 0, 0, and a radius of a. So I have that circle drawn right here, where the circle is centered at 0, 0, and you're going out a in every direction. It says this circle is going to be the base of the solid, and we're trying to find the volume of the solid where the cross-section is going to be a square, where the square is a plane that's perpendicular to the x-axis. So that's why I have that line drawn right there. You can see over here the diagram kind of gives you a better idea, where you have the side of the square that's bounded by the circle, and the square is coming up out of the graph. And what's happening is we're drawing an infinite number of squares from negative a to positive a that are all perpendicular to the x-axis. So here's a diagram that demonstrates this a little bit better. Before we set up our integral to find the volume of this solid, first I want to look at the equation x squared plus y squared equals a squared. What we're going to do is we're going to solve this for y. So first we subtract x squared over, and then we're going to square root both sides. So we get that y is equal to plus or minus the square root of a squared minus x squared. So this equation still describes this circle. It's just that the positive square root is equal to the top half of the circle, and the negative square root is the bottom half of the circle. So right here I drew an arrow, and that's indicating that from the x-axis up to the top half of the circle is going to be the positive square root. So again, y equals the square root of a squared minus x squared is going to be from here to here of this segment. You can see for your square though, the whole segment is the side of the square. So I have that part of the segment labeled here. Again, that's going to be y equals the square root of a squared minus x squared. To find our volume, because the cross sections are perpendicular to the x-axis, it's going to be a dx problem. And you can see that we're integrating from negative a to positive a. So to find the volume, you set up your integral from negative a to positive a of a of x dx, where a of x is the area of the cross-section. Okay, one thing I want to point out here is when you look at this region, you have y-axis symmetry, and so because we have y-axis symmetry, integrating from negative a to positive a is the same as integrating from 0 to a and then timesing by 2. So I have that set up, 2 times the integral from 0 to a of x dx. Okay, next we have a of x is the area of the square, and a square's area is the side squared. If from here to here is y equals the square root of a squared minus x squared, the whole side would be 2 times this. So 2 times this expression is the side of the square, and the area of a square is that side squared. And I just made a note that a of x is the area of the square, and the area of a square is the side squared. So this is the expression for the side of the square, and then we square it. So next we're going to square this expression. So 2 times 2 is going to be 4, and I'm going to bring that to the front to make a total of 8. The square root and the square, they undo each other so that all we have left is a squared minus x squared. We're going to integrate with respect to x. A is a constant, so when you integrate a constant with respect to x, it's just going to be that constant times x. So again, the integral of a squared is going to be a squared x. The integral of x squared is going to be 1/3 x cubed. And now we're going to evaluate this by plugging in a for x minus plugging in 0 for x. So here we plugged in a for x, and then when you plug in 0 for x, you just get 0. So now we have 1a cubed minus 1/3 a cubed is going to make 2/3 a cubed. So our final answer for the volume of the known cross-section is 16/3 a cubed, where a is the radius of the circle. This example says a solid has its base, the region on the xy plane bounded by the graphs of y equals 4 and y equals x squared. Find the volume of the solid if every cross-section by the plane perpendicular to the x-axis is an isosceles right triangle with hypotenuse on the xy plane. So again, we have our base is going to be y equals x squared, bounded by the line y equals 4 right here. And if this is y equals 4 and this is y equals x squared, if we take 4 and plug it in right here, you get 4 equals x squared. So that means x equals 2 and negative 2 is where the graphs intersect. And finally, the cross-sections are perpendicular to the x-axis, so I have this line drawn right here that's perpendicular to the x-axis. And the cross-section is an isosceles right triangle where the hypotenuse is on the xy plane, so this line is going to be the hypotenuse of our isosceles right triangle. So I made this line correspond to this right here in this diagram. So here's your isosceles right triangle, where this is the hypotenuse, and that means that these are going to be 45-degree angles. So for this line segment, it's bounded by the line y equals 4 and the line y equals x squared. So to write an expression to represent it, we're going to do 4 minus x squared. So I have that written here. 4 minus x squared is going to be the length of the hypotenuse. So to get from the hypotenuse back to a side, you're going to divide by root 2. So that's why we're taking this expression and we're dividing by root 2, and that's the length of both of these sides. To find the volume of our solid, again, because the cross-sections are perpendicular to the x-axis, it's a dx problem. So to set up our integral for the volume, we're integrating from -2 to +2 of a of x dx, where a of x is the area of the cross-section. You can see in this region that we have y-axis symmetry, so integrating from -2 to +2 is the same as integrating from 0 to 2 and timesing by 2. So we're going to rewrite this as 2, the integral from 0 to 2 of a of x dx. All right, at this point we have a of x is the area of the cross-section, which is the area of a triangle. And the area of a triangle is 1/2 base height. By definition of base and height, they have to be two sides of the triangle that are separated by a right angle. So we're going to use these two sides for our base and height of the triangle. So we have 1/2 base and height, again where base and height are both 4 minus x squared over root 2. So again, when we pull this out, those 2's cancel. Root 2 times root 2 is just 2, and that comes out as a 1/2. So next we're going to FOIL this out. So now we're ready to integrate. So next we're going to plug in 2 for x minus plugging in 0. So when we plug in 2 here, we get 32. When we plug in 2 here, we get 8. And then 8 times -8 is going to be -64 over 3. And then we plug in 2 right here, we get 32 over 5. When we plug in 0, we just get 0. And then now we're going to simplify this. So for our final answer, we get 128 over 15. This example says a solid has its base, the region in the xy plane bounded by the graphs of y squared equals 4x and x equals 4. If every cross-section by the plane perpendicular to the y-axis is a semicircle, find the volume of the solid. So this is a parabola with a vertex at 0, 0 that opens to the right, and then we have the vertical line x equals 4. If we take 4 and plug it in right here for x, then we get y squared equals 16, and that means that y is equal to plus or minus 4, and that's going to be the y-coordinates of the points of intersection of the two curves. The cross-section is a semicircle, so I drew a semicircle here where this line segment in bold corresponds to the diameter of the semicircle. So I rewrote this equation so that it's in x equals form, so we get x is equal to 1/4 y squared. So we can use this expression for the parabola. And to write an expression for this segment, it's going to be x right minus x left. So the x on the right is 4 minus the x on the left is 1/4 y squared. So this is the expression for the diameter of the semicircle. Because the cross-sections are perpendicular to the y-axis, this is going to be a dy problem. So we set up the formula for the volume as the integral from -4 to +4 of a of y dy. And again, our limits go from -4 to +4 because this region exists in the y direction from -4 up to +4. You can also see that this region has x-axis symmetry, so integrating from -4 to +4 is the same as integrating from 0 to 4 and then timesing by 2. So we have that set up, so now we just want to write the area of the cross-section, which is the area of a semicircle. So the radius of the semicircle is going to be 1/2 the diameter. Again, this is the diameter, so we do 1/2 4 minus 1/4 y squared. When we distribute the 1/2 to both of these, we're going to get 2 minus 1/8 y squared. And the area of a semicircle is 1/2 pi r squared. So for a of y, we're writing 1/2 pi and then the radius squared. All right, at this point, this 1/2 will bring it to the front, and then those 2's are going to cancel, and then we're going to pull the pi to the front as well. Next, we're going to FOIL this. So when we FOIL, we get 2 times 2 makes 4. For the outer term, we get -1/4 y squared, and for the inner term, we also get -1/4 y squared. So -1/4 y squared and another -1/4 y squared makes -1/2 y squared. And to get the last term, we multiply these together, and we get +1 over 64 y to the 4th. And now we're ready to integrate. Next, we're going to plug 4 in for y, minus plugging in 0 for y. And then finally, common denominator is going to be 15. So our final answer for the volume is 128 over 15 pi. This example says a solid with a circular base and a radius of 1 has parallel cross-sections of equal lateral triangles perpendicular to the x-axis. Find the volume of the solid. So here we have our circle with center 0, 0 and radius of 1. Our cross-section is an equilateral triangle, so this is going to be one of the sides that's perpendicular to the x-axis, and you can see that this is bounded by the circle. So this line corresponds to this side of the triangle. If it's an equilateral triangle, that means all the angles are 60 degrees. So here's 60, 60, and then this would be 60. And then I drew a line here splitting it in the middle so that we get 30 degrees and 30 degrees. The equation of the circle is going to be x squared plus y squared equals 1. Next, we're going to solve for y. So we get y equals plus or minus the square root of 1 minus x squared. The plus or minus square root indicates the top half of the circle and the bottom half. So when we have y is just from here to here, that y is equal to the positive square root of 1 minus x squared. So this part of the segment corresponds to right here, and that's y equals the square root of 1 minus x squared. This is a 30, 60, 90 triangle. If you have a short side and you need to get to the long side, then you times this by root 3. So the length of this side is going to be root 3 times the square root of 1 minus x squared. Because our cross-sections are perpendicular to the x-axis, this is going to be a dx problem. So our volume is going to be the integral from -1 to 1 of a of x dx. You can see integrating from -1 to 1, because the region has y-axis symmetry, is the same as integrating from 0 to 1 and timesing by 2. And this a of x represents the area of the triangle. And again, for the area of a triangle, the base and the height need to meet at a right angle. The base is the entire length. If this is y equals the square root of 1 minus x squared, the whole length would be 2 times this expression. So I put 2 times the square root of 1 minus x squared as the base, and then this will be the height right here. All right, so at this point, these 2's are going to cancel, and then I'm going to bring this root 3 to the outside. Next, the square root of 1 minus x squared times itself is going to be just the expression 1 minus x squared without the square root. And now we're ready to integrate. So we're going to plug in 1 minus plugging in 0, and 1 take away 1/3 is 2/3. So our final answer for the volume is 4 root 3 over 3. All right, guys, thanks so much for watching.